I hope you guys had a good roll at things, being able to take some time off for MEA. We do have, obviously, our Thanksgiving break, but that's it. So we just have, Thanksgiving and Fridays. So, we'll be ready to go here. So, okay, we pick up from when we were gone. Derivative of sine, do you remember? Cosine. Now, we did a page-long proof of that using the sandwich theorem, if you remember. We did some interesting substitutions, but we got derivative of sine of x is cosine of x. Now, we could do the same type of problem, and we would get the derivative of cosine is negative sine of x. We could rewrite tangent to be sine of x over cosine of x. And what rule would we have to use then? The quotient rule. If you use the quotient rule, you come up with the derivative tangent of x is equal to secant squared of x. The derivative of cosecant, we're actually going to do a short proof to show you how easy that can be. Flip it over to the next page. And it says, example 3, prove that the derivative of cosecant is negative cosecant cotangent times cotangent. So I'm going to do that. But I'm going to rewrite it as the derivative of 1 over the sine of x. d over dx is another word for derivative, yes. So I'm going to use the quotient rule. I take the derivative of the top, which is 0. So I'll write this in case you don't remember. F prime g minus g prime f all over g squared. This is something you're going to use just about on a daily basis now. You'll start to remember it even better. Derivative of the top is 0 times sine will be 0 minus, what's the derivative of the bottom? Cosine. Just because we stated that the derivative of sine is cosine. And times the top is 1 over the bottom squared. Now I have to make that look like negative cosecant cotangent. Can somebody tell me how I can start to make that look like negative cosecant cotangent? Okay, so I'll rewrite it as negative cosine of x over sine squared of x. Great. Now what? Come on, geniuses. Very good. Negative 1 over sine times cosine over sine. What's negative 1 over sine? Negative cosecant. And what's cosine over sine? Cotangent. So my proof is done. I've shown that the derivative of cosecant using the quotient rule is negative cosecant times cotangent. Okay with that? So we'll finish off listing these derivatives. Flip back over the other side. So the derivative of cosecant is negative cosecant of x, cotangent of x. Derivative of secant is secant of x times tangent of x. And the derivative of cotangent is negative cosecant squared. Now we've got just a minute left before lunch. I'm going to show you a little bit how I remember these. I always remember this one. And once I remember that one, it tells me this one. I always remember this one. And once I remember that, it tells me this one. And I always remember this one. And once I know it, it tells me that one right there. So you're going to have to know these 3 for your test, or these 6, okay? This is part of the memorization you will have to do. And I know from your other classes you're good at memorization. I will also say that if you look at your sheets, that I tell you here, the derivatives, they're listed right here. So that way if you ever need to reference them, product rule, quotient rule, power rule, and those derivatives. Go get some brain food. We'll pick up when you get back. Try some examples. All right, here we go. So we this sheet, various calculus notes. You're going to want to have that out each time we kind of get to this part of the class. Hopefully you had a good lunch. I had ham and cheese as usual. Every day. Every day. Okay. No, I do not. Just like I don't get sick of calculus. It's beautiful every day. Every day, ham and cheese sandwich and pretzels. No, I like it. Nope. I love my wife more. I have a Mountain Dew. I do. I need more nutrition. I'll have an apple when I get home. Kids are math. I love my kids more. You guys are math? Holy cow. We might have to do a 1-by-1 situation here if I do that. Okay. Let's take the derivative of the following. Derivative, negative 4x. Derivative of tangent. And that's it. Is that nice? Negative 4 plus secant squared of x. So, pretty easy derivative. Next one. The 3 is just a constant, just comes along for the ride. So derivative of sine is, cosine will be 3 cosine of x minus 4 sine of x. Because the derivative of cosine is negative sine. If you want to know why, we could do the sandwich theorem proof and show you why. Okay. All right, the next one. See if you can understand this piece. It's a little bit different. You know the derivative of 3x, and that's plus. But now x cotangent of x. Who has an idea of what I should do in that situation? The derivative of x is 1, but notice that these are two functions that are being multiplied together. So therefore, for this piece, you must use the... Okay, all right. We're kicking you out of class. Like, you weren't even close. I guess it starts with a P. Product rule. There you go. So that's F, and that's G. So I'm going to do F prime G times, or plus G prime F. So what's F prime? 1 times G. So cotangent of X. Plus, what's G prime? Negative cosecant squared times F. Yes, derivative cotangent is negative. Wait a minute. Yeah, derivative cotangent is negative cosecant squared. So as I rewrite this, I'll rewrite it as 3 plus the cotangent of x minus x cosecant squared of x. How's that? I just put it in the front. That way it won't be confused with that x there. Are the nicer way of writing things. Okay, so you see that? Now you understand why using the product rule is going to be important as we encounter these type of situations. When you're using trig stuff, you'll often come across, quotient rule, product rule. Next one, instead of using the product rule, you're going to want to use the quotient rule. But if you remember the wonderful time we had in trigonometry last spring, it was beautiful, wasn't it? Missing day after day due to golf meets, falling asleep 7th hour, just those wonderful times. Maybe you remember that we can rewrite this, and if you wanted to use the quotient rule, you sure could, but it's going to be easier to do this. Do you remember that cosine and secant are reciprocals? So therefore, instead of using the quotient rule, I just take the derivative. What's the derivative of secant? Very good. Now, let's try a couple that are actually a little bit more complicated. So we've seen a nice basis for beginning, but we'll try these next two. These are a little bit more challenging. No way around rewriting letter E. I'm going to have to use the quotient rule. So I have f prime of x is equal to, what's the derivative of the top? Cosine of x times the bottom left alone, x plus cosine of x, minus the derivative of the bottom is not just negative sine of x, but 1 minus sine of x, times the top, 1 plus sine of x, all over the bottom squared. What? The quotient rule? No. D, I just rewrote it. Instead of a 2 cosine, I rewrote it as 2 secant. That way it made it easy. Okay, something's going to cancel out here, but I won't know until I start distributing through. And we'll see who can pick up on it. You're going to have to remember some of your trig in order to get this correct. So I'm going to have x cosine of x plus cosine squared of x. And then if I take 1 minus sine times 1 plus sine, what am I going to get? Right, 1 minus sine squared. If I distribute the negative, I'll get a minus 1 and a plus sine squared. All over x plus cosine of x quantity squared. And now I wait for you guys to see something. Sine squared plus cosine squared is 1. Minus 1 is, so this all goes away. Now again, as I gave you that sheet, you can see that if you forget some of these useful substitutions, there you have it, cosine squared plus sine squared is 1. That's listed for you right there. Probably the most important trigonometric identity you need to know. Pythagorean identities. Very good. So we will head back here, and we have, again, f prime of x is equal to x cosine of x over x plus cosine of x, that quantity squared. So they're very similar, aren't they? No, you just, that's the answer. Okay, for letter F, we just have 2 examples left. We're going to do letter F, then we're going to do 1 example on the back side. I have 2 possible approaches to this problem. Somebody see what rule is required here. The product rule is required. If I were to distribute the secant through, I would get f of x is equal to theta secant of theta plus secant of theta tangent of theta. Now, if I decide to distribute through, how many times would I have to use the product rule then? I'd have to use it twice, right? So we can either leave it like it is at the beginning and do the product rule once, or we could do it like it is at the end and do it twice. Which would you rather do? Okay, it's totally up to you. It doesn't matter to me. So let's do the product rule, and we'll do it once. So f prime of x is going to be a little bit long. Derivative secant. I guess this is technically incorrect. It says f of x. Technically, it should say f of theta. Maybe I should change my notes and look like a real mathematician, huh? All right. F of theta will be secant of theta, tangent of theta, you said, times then the second part left alone, theta plus tangent of theta. How we do that? Plus, now I leave the secant alone, right? Times, what's the derivative of theta? 1 plus derivative of tangent, secant squared theta. Yeah, close. It would be like the derivative of x. Derivative of x is 1. The derivative is a constant. It has a constant slope. Okay, so therefore, I would hope that something would maybe cancel out here. 1 plus secant squared, is that something special on our sheet? I know if I get ones and squareds that usually something matches up, but it doesn't match up, does it? Secant squared minus 1 is tangent squared, right? So I don't have that here. So we're going to have to distribute and see if something's going to cancel eventually. And you could give the nasty look on your face. The whole, yeah, there you go. Okay, she did not like that. Okay, we're going to distribute. I get theta, secant of theta, tangent of theta. As I distribute that first part through, as I distribute the second part through, I get, let's see here, plus secant of theta, tangent squared of theta. And if I distribute secant, I get secant of theta plus secant to the third theta. Okay. Everything has what? A secant. So I'm going to try to take out a secant and see if maybe there's something left over that would cancel. If I take out a secant, I'm left with theta times tangent of theta plus tangent squared of theta plus 1 plus secant squared of theta. Oh, I see something. Tangent squared plus 1 is secant squared. So how many secant squareds will I have? 2 of them. So therefore, f prime of theta is equal to secant of theta times theta tangent of theta plus 2 secant squared of theta. That is secant squared. So I have now 2 of them. Not too bad, huh? My definition of not too bad is if you don't like that and you don't appreciate how nice that is, then go ahead and do this instead. Take the limit as h goes to 0 of f of x plus h minus f of x all over h. Why don't you figure out the derivative that way and see if you don't appreciate this more? Yeah, Adam. Yeah, not too bad. So, yep. It looks like a pretty ugly derivative, but looks aren't everything, right? So, all right. So, let's tie it all together. Remember at the very beginning, we asked this question, what is the slope, or what is the equation for a line tangent to a curve at a given point? We're always going to come back to that in different contexts. Now, the last 2 problems of your final exam were problems just like that. First problem is a little bit easier. Second problem is a little bit more difficult. But if I want to write equation for a tangent line, what 2 things do I need? Yeah. And, well, the point on the line is going to be pi over 6 is the x value. How would I come up with the y value? Plug it in. Well, I have to know what sine of pi over 6 is. You should. But you don't because you had a bad trig teacher. Yes, very good. How'd you know? Hey, well, I'm going to teach you guys how to make the unit circle. So let's do that. Okay. Pi over 6 is how many degrees? 30 degrees. You multiply by 180 over pi. So I have 30 degrees. And what is always the radius of the unit circle? 1. That's why I called the unit circle. What is the opposite side of 30 degrees? Half. And then what do we multiply by to get the other side? Square root of 3 over 2. So this has a coordinate. It has a terminal point location of square root of 3 over 2, 1/2. Is sine the x value or the y value? Sine is the y value. So sine of pi over 6 is 1/2, and 1 minus a half is a half. Why are we doing this by hand? Because half the AP exam is by hand. Okay, how do I find slope? What do I do to find slope? Take the derivative. Take the derivative, and I get, what's the derivative of 1? What's the derivative of sine? So I have a negative cosine of x. Great. Negative cosine of x. Is cosine the x value or the y value? It's the x value. So cosine of pi over 6 is, or negative cosine of pi over 6 is going to be negative root of 3 over 2. So now I will write y minus a half is equal to negative root of 3 over 2 times x minus pi over 6. And on the AP exam, you could leave it as that. But in this class, you cannot. You need to write it in slope-intercept form. So I have y is equal to negative root of 3 over 2 times x. As I distribute the negative root of 3 over 2, I get plus pi roots of 3 over 12. And then as I add the 1/2 will be over here. I have my slope, but I need a y-intercept. What is the common denominator? 12, so I have y is equal to negative root of 3 over 2 times x. And then if I multiply top and bottom by 6, I will get 6 plus pi roots of 3 all over 12. And so that is the equation for my line tangent at that point. Well, I just want to confirm that my answer is correct. So in order to confirm it, I'm going to graph it. I'm going to graph 1 minus the sine of x. And you guys know what that looks like. Yes, I should be in radians. Very good. And then as I'm in y equals, I'll type in this part, which is negative root of 3 divided by 2 times x plus parentheses 6 plus pi roots of 3 divided by 12. And let's graph it and see what we get. Whoop. I'm going to have to change my window here. Come on. Doesn't look too good, huh? Window, let's change our x values to negative 6 to positive 6. And we'll try one more time. I'm not happy with that at all. What is pi over 6? What is pi over 6? It's like 0.5, right? Oh, right there. Thank you, Maddie and Adam. There we go. Is that line tangent? You better believe it. Okay, pretty sweet. Like it. Okay, yeah, you take all the credit. Okay, I know what you want. You want an assignment. Now, I warn you, raise your hand if you've ever been a putz during this first quarter. If you are a putz during this unit, you will pay for it. This test will destroy you. I promise. So, stay on top of your stuff because it will get the better of you. I promise. There's your assignment.